And I'm back. We'll discuss question 4 now. Can everyone hear me and see my screen? Can everyone hear me? Okay, thanks. All right, so now this is a scenario in this question, right? You have basically a laser scanner, right? So some sort of LiDAR. Sorry, I just draw a circle. Right, and it has a imagine there's a coordinate frame defined at the LiDAR, right? So say XY, right? And it has a field of view ranging from plus 45 to minus 45, right? So that is plus 45 to minus 45, right? And we've been given 1, 2, 3, 4, 5, 6, 7 ranges, right? So basically the laser has in one sweep gone through 7 locations, right? So that would mean something like this, right? So this laser is rotating, and each time it returns back a data in a single rotation, you're getting 7 different readings, right? So an array of 7 different readings, range values, right? So what is the value of one of these angles? It's 15, right? So you have 15 degrees per per angle increment, because you have minus 45 to plus 45, and you have 7 readings, right? So you will have 1, 2, 3, 4, 5, 6, 7, and if each of these represent about 15 represent 15 degrees, that covers this 90-degree field of view. Okay, so what we're going to do now is try and plot this data and see what it looks like, right? So these are the ranges I've given you guys, right? And now we need to kind of get the angles, right? So a really easy way to do that is you can use MATLAB's function line space, right? So what line space does is you can type help line space, and it will tell you the how to use it. So this second use of it, you can generate endpoints between x1 and x2, right? So for example, let's say you want to divide points between 0 to 10, and you want to divide it into 5, right? What you would do is use this, and here you'd give 0, here you'd give 10, and here you give 5, and it will divide it into 5 points, including the ends, right? So it will look like this. Cool. So yeah, it'll include the 2 endpoints as well, 0 and 10, which is kind of what we want here as well. We want the starting point here, which is 45, minus 45, and all the angles in between, right? So if I say line space minus 45 to plus 45, 7, it will give me all those angles, right, measured from this point, right? So it will give me plus 15, 30, and 45, and then minus 15, 30, and 45, right? So if I run this, for example, see, I'm getting all the angles that I need: minus 45, minus 30, minus 15, 0, 15, 30, 45, right? So each of these ranges will correspond to one of these angles, right? So if we want to plot it, we need to convert these ranges and angles now into Cartesian coordinates. So I'm going to do that using this easy to understand function, right? I'm taking these ranges and multiplying it. So this dot multiplication means we are not doing a matrix multiplication, we are multiplying element wise. So costs, and so MATLAB's cost functions take radian values. I've arranged these angles in degrees, so I have to convert from degrees to radians, which is why I've used this function, and then I include these angles in there, right? And then I'll get my x values and y values. Another way you can get these x values and y values is there's a function called Poll to Cart, right? That converts basically. So if you say help Poll to Cart, you can give a bunch of ranges and angles and get basically a conversion between. So these type of coordinates are what we call polar coordinates, right? Where we have points represented as ranges and angles, ranges and bearings. This is called polar coordinates, and we want to convert it into Cartesian coordinates, x, y, right? So MATLAB has a function called POL to CART, right? Poll to Cart, that converts from polar coordinates to Cartesian coordinates. So you can either do it yourself by multiplying r into cos theta and r into sin theta, or you can use this Poll to Cart function, right? Whatever you like to kind of use. And then what we can say is plot x vals y vals. So if I run this, I will get the plotted out values. Cool. Any questions? Does everyone understand what happened and how a laser rangefinder works? How a LiDAR works? So by the way, this is a 2D LiDAR, right? We've only considered everything happening in a single plane, but obviously what you can do is you can have multiple lasers like this stacked up on each other, and you can get a 3D kind of volumetric information about the environment, and get what we call a 3D point cloud of the data. So what that generally looks like is something like this. So you guys might have seen stuff like this, right? So this is what it looks like if you had a 3D LiDAR, right? Basically, you won't just have a 2D scan, you'll have all the 3D information, the height as well, right? So generally, these kind of LiDARs are really, really expensive. But 2D LiDARs are, you get, again, really good quality ones are really expensive, but you also can find like cheap ones on like your Turtlebots and things like that as well. So the more of these lines there are, right? The more of these lines there are, the more higher resolution you will get, right? And obviously, the higher the field of view that you can handle, that's also pretty good if you can get a full 360 coverage. Okay, so that's question 4. Now we'll look at question 5. Right, so question 5 is not MATLAB, it's just basically you have to look at this image and kind of take a few minutes and figure out what has happened between the two scans, right? So what question 5 and 6 is going to help you guys understand is basically the scans that you're getting are not stationary. Your robot is moving, right? So for example, if the robot is over here and gets a scan, right, of a certain location, when the robot moves, that same scan is from this angle now, and then this angle, right? So the robot is moving, and objects in the environment will kind of change because from the sensor's perspective, you're looking at the object from different sides, right? And what happens then is your laser scans will have rotations and translations, right? So imagine this is your first scan at T1 and this is the same object but from a different location. By looking at what happened to the object that you're seeing, you can figure out how you have moved, right, in between. So for example, what I mean by that is, let's say we have an object that looks like this, right? And I'm looking at it from here first. So my scan, I'm getting this section, right? And then my robot moves down here. And now I'm getting this section. Let me use a different color for that. Now I'm getting, say, this section from my laser scanner, right? By looking at these two scans, the first scan I have is like this, and my second scan looks like this. I can kind of figure out, if I can match this to this section, I can figure out how the robot has moved, right? So that's kind of what we are doing here. By looking at how this transforms, how the object transforms, we can kind of figure out the rotation and translation of the robot, right? So can you guys take like 2-3 minutes and see if you can do question number 5? You don't have to use MATLAB, just take a piece of pen and paper and see if you can, or just look at this image and see what has happened in terms of translation and rotation. I'll give you like 2-3 minutes.